We've been having a lot of fun as we've gone through the routing table, acting like a detective, decoding and understanding each of the elements to better understand the routing table. So what I'd love to do with you in this video is do a few practice questions to help reinforce those concepts before we move on to the next skill. So if you're ready, take one. And for these questions, we're going to leverage the output of this show IP route command on a Cisco router, and I'm going to use the same exact output for each of the questions. So it's not like you have to reinvestigate the whole routing table from scratch. We get to use the same output as we look at each of the questions. So the first question is, what is the source of the route for 10.16.7.0/28? And as a starting point, let's find that here in the routing table. It is right here. And the question is, how did that route get into this router's routing table? And one of our objectives for you and I in this review video is that instead of just giving a list like a multiple choice, I want us to just use everything that we've learned and studied together and think these questions through, because this more reflects like a production environment when we're wondering, how did that route get there? So let's take a look at this route and make a deduction about how this route got into the routing table. So the routing protocol code over here says C, which implies directly connected. It also says that right here. So it's very likely that this route got in the routing table because the administrator went to this interface, gig00, configured an IP address on that interface, something in the 10.16.7 subnet, brought that interface up, and boom, we're now directly connected. So this route got in the routing table because there's an interface, this specific interface, with an IP address configured on it. Question number 2. Why does the routing table have entries for 10.16.0.0 twice? Let's take a look at that. So right here, that does indeed look like 10.16.0.0 in there twice. Why is that? Give that some thought. We'll compare notes in just a moment. And the reason that 10.16.0.0 is in there twice, or at least visually looks like it's in there twice, is because those are two different networks. The first one is a 21-bit network, and the second entry, the second route, is for a 24-bit network. So from a routing perspective, the router is considering those to be two very distinct and separate routes, and it's keeping them both in the routing table. Question number 3. What is the next hop address for packets being routed towards network 10.16.7.0 to 28-bit mask? So that is this route right here. And the question is, what is the next hop address for that route? Now, I want to give you a bit of warning regarding this question, and that is, it is a little bit of a trick question. It's a little bit tricky. So take another look, and then let's compare notes together. So let's walk through the solution to this. If this is our router, so we'll put our router here, and for this route 10.16.7, it's gig00, so we can put gig 0/0 there. So it's connected to this network. If this router received a packet destined for a host at 10.16.7. Let's imagine it was .8 or .9 or some IP address on that subnet. This router, believing that he's directly connected to that network, which he is, would go ahead and deliver that packet directly to the host. So if this is the PC or the host at .9, it would just go ahead and forward the packet directly to that host because it's directly connected, the router is directly connected to that network. So in this example, there is not a next hop address for the next router in the path because we are at the end of the road. We are directly connected to that network. So in answer to the question, there isn't a router next hop address. The next device it's going to is this PC at .9 on that local network. So if this same question had been asked for these routes right here, they do indeed have a next hop address. That's this one right here, regarding the IP address of the next hop, the next router in the path towards the final destination. All right, our next question, question number 4. What is the administrative distance for the route to 10.16.4.0 based on the output here of the show IP route command? So as part of this task, we'd first find that route, which is right here, the 10.16.4 network. It was learned via OSPF. The next hop is the router at 10.16.7.5. The egress interface is going to be gig 00. But regarding our question of the AD, the administrative distance for this route is this first number right here, which is 110, which happens to be the default administrative distance for routes that were learned via OSPF. And then this 3 following that is the metric. In the case of OSPF, that would be the cost. Which leads us to this next question regarding the metric or OSPF cost for a route to 1111 with a 32-bit mask. So that would be like a host route. So my question regarding that route, what is the OSPF cost associated with that route? So in the routing table, we find the route. There it is. And the cost is this number right here. So it's the administrative distance first, followed by the cost. So the cost would be a cost of 2 for that route. And question number 6. How was the default route learned? And what is the AD for that route based on this output of the show IP route command? So to discover this, we'd first of all look for the default route, which is this guy right here. And then the question is, how is it learned? And we look at the routing protocol code that's next to that, which is an O, capital O, which is OSPF. So it was learned via OSPF. And what is the administrative distance? And that administrative distance is listed right here. That first number in the brackets, which is the administrative distance, followed by the cost. So I'd like to thank you for joining me, both for the videos as part of interpreting an IP routing table and also for this review. And I'll see you, my friend, in our very next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.